Welcome, Mary.
Hello, Helen. Hello, everybody. Thank you. Thank you so much again. I'm like you said, right, Helen, we're having a party here today. No, but sorry, don't make me spoil.
So many faces. Most important question, Mary. Was there a boat trip for JConf?
I almost fell off the chair when you mentioned about that boat trip. It was such lovely time we all had. But yeah,
It was a good boat trip for the audience. It was just a bit unfortunate that it was quite choppy as well.
That's right. But otherwise, otherwise it was actually very nice. Yeah.
Otherwise, it was fantastic. So are you joining us from Chicago today, Mary?
Yeah.
Okay. So I would love to go back there one day. It was. I think I was there about 10 years ago, so I'm sure it's changed quite a lot.
Yeah, it has. In fact, I wanted to mention we just had the JConf, which the Atlanta Jug folks were here. Well, it's their conference, but they're hosting it here in Chicago. So we just finished. So as such, I just finished with that, and I'm still in Chicago, literally, because I live out in the suburbs. So I have to drive home, but that's okay. I'm going to do this presentation here. So, yeah.
Thank you so much for joining us, especially as you've just come off one conference. Much appreciated.
Yeah.
So we asked all our speakers, as our audience has probably gathered by now, for some fun facts, and Mary shared a couple of those with us. So one of Mary's first interesting piece of information, which I didn't know, that you were a soccer mum when your daughter was growing up, and you travelled a lot with your daughter playing. She was playing in youth soccer programs.
Yeah.
And I guess my question is, how old's your daughter now, and does she still play soccer?
She only plays recreationally now, and she is working in the working age, and she is in her mid-20s, and so but she still loves it, and she coaches it too in her spare time. Or just kind of for fun. Cool. Yeah. So and so I was a soccer mom. I was traveling, so I'm really used to this traveling lifestyle, so to speak. Yeah. In fact, I'm like, great, I can travel again. So
stay here, do it.
Just you meet people, talk with people, watch a game, and all these, and it's kind of same thing, right? You go to conferences, you talk with people, see people talk, and you're learning. You're just observing things, meeting people. So
absolutely,
it's kind of exciting. Yeah. So
all right. Yeah. Okay, so down to business. This talk is for you, especially if you're interested in event streaming. Mary, you're going to take us through how event streaming is meant for anyone who's interested in learning about it and understanding how it fits in the modern software development, design, and architecture. We're going to be looking at the open source platform Apache Pulsar, which I'm looking forward to learning about, because it is poised to become the de facto new generation of distributed messaging and streaming platform for developers to enable their systems and applications to be highly responsive with real-time capabilities. I like the sound of responsible applications. So, Mary, I'm going to add your desktop to the stream, and I'm going to remove myself and have fun. Thank you.
Thank you. Thanks, Helen. And thank you again, everybody, for coming to my talk. Actually, I realized I did not share my desktop. I thought I already was sharing it. I'm so sorry. Let me share it. So I think you should be able to seeing it full screen. Okay, I'm double checking. Okay, cool. So thank you everybody again for joining me with this talk. I hope you'll find it useful. Again, I won't spend the time talking too much about it because Helen already did a fantastic job doing the introduction. But first of all, if you are interested in this slide deck and wanting to also have a copy of it while I'm presenting, here is the bit.ly link and also a QR code if you want to do a quick scan of it. I'll leave this on for like a couple of seconds so you can kind of quickly get that. But then again, if you miss it, if you decide not to have it now but want it later, I will make this slide deck available to the organizers too. So again, just so happy to be here. Really fantastic team too here at the IntelliJ so the IntelliJ team, advocacy team, right? Helen, Mala, Merritt, right? And I think you may be having new folks too joining, but anyway, so really lovely to see all of you here, and Alexander at the background too, helping, right? All the backstage. So here I go. Okay, so here I won't show all of the details we already know. Helen already talked about it. And then this is just another, from my company, this is just the boilerplate, so to speak. All of us, each advocate, we have this kind of pictorial representation of us. So yeah, you already know about me, so I will skim through. And let me then start. So the agenda for today, right? Essentially, too, I wanted to start a bit to talking about some basic concepts, because I have to assume that not everybody coming here already have been working with events of any kind, right? Event streaming, whether it is event processing, you're getting event data, ingesting it, and some complex event processing, messaging, all of these, and they can be confusing too, in fact. And I also am finding that some folks, if you've been doing programming development for a long time, you may not actually have worked with events yet. So I like to do a bit of a kind of introduction type of materials first. So for those of you who are familiar with it, who are expert, please bear with me. And then after that, some introduction of these terminologies, all of these things, I'll get into Pulsar, but also describe to you like why do we need event streaming and what is it for, right? Exactly. And then also introduce you to Apache Pulsar's dependencies on Zookeeper and also Bookkeeper. Those are also Apache open source project. And then I'll highlight a couple of developer features, then also show you just quick demo thing. Nothing like way too fancy. This is as such, a regular presentation session. So, but just to kind of give you a taste of it, about, if you want to quickly set up your stream and started coding, what would you do type of thing. And then, yeah, that will be pretty much, the content for this particular session. So let me start the many facets, right, of computing events. So I wanted to start by kind of giving, kind of every one of us an understanding of what event is, right, within the context of computing. But let's kind of understand to event, right, it can mean many things to different people and different contexts, and in fact, too, why I thought it would be good to just talk about, breaking things down, so to speak, into small pieces. It's more like, us, right, human beings, any kind of things, right, we break it down into the really primitive form. It would be an atom, right? An atom is what, kind of all forms of all beings are, an atom. So here is that we're talking about computing events and such an exciting, topic area. I think it's also one of the kind of most challenging aspects of computing, I think. But anyway, let's get back to some basics. So what is it that we are trying to deal with, right? What is an event, right? Generically speaking. So I looked up Merriam-Webster.com, the dictionary giant, right? And the online version. The first description, it means something that just happens. It's an occurrence. It can be, you're going to a music like a concert, right? A musical event, that's an event. And also too, because I got asked when I submitted proposals to some conferences, actually the organizer reached out to me and said, what are you talking about event processing? And it's, so to me, I kind of can understand sometimes you like, events, computer programming development. So that's what it is. So something that just happens. But for us who are programmers, right? Developers, we're more of the nerds, right? And we like all the kind of abstract things, right? To abstract kind of computing things, scientific way of interpreting. So based on the theory of relativity. So it's, as you can see, this point I highlighted here, the fundamental entity of observed physical reality represented by a point designated by 3 coordinates of place and 1 of time in the space-time continuum. So that's from the theory of relativity, and I like that. And you may be thinking, oh, gee, getting into theory. No, that's not what we're trying to do. But it's kind of interesting to kind of think of it in your mind what this is, right? We're talking about XYZ coordinate. So that's the place. Interesting thing about computing events is that it also brings in a 4th dimension, which is time. So which means that events, travel through time, and at any given point in this space-time kind of space, you should say, right? It keeps changing, right? It's pretty abstract if you think about it. So to me, I think it's interesting. And of course, if you put things together, you've tried to do computation over it. It's never very easy when you need to consider time. It always kind of kind of complicate things, right? It's not as easy because the state of your data keeps changing, and you need to be able to track them, and that's kind of the challenges of it. And of course, too, that's kind of one aspect of it. But the other aspect of all of these capturing of data traveling through time has its purpose too. And what is the value to us, right? So it actually helps us to figure things out, do analysis, right? Doing recommendations, doing fraud detection, for example, things like that. So I'll be talking some more in a little bit. So, okay, so here then getting a bit then into this today's topic, event streaming processing, is essentially the practice, right, of taking action on this series of data points that originate from a system. The system will continuously create data too. So the event will refers to each data point in the system, and then the stream is kind of referring to this ongoing delivery of these events. So as you can see, any kind of system, right, we're dealing with streams of data. They can be very messy, a lot of them, and you need to track them. And they all happening at different times and things like that. So a series of all of these events then are essentially being referred to as streaming data or data streams, right? So, but one thing I wanted to point out too is that, yeah, we are using this word streaming everywhere now. And in fact, there are people who are non-computer. It can be like a generic consumer term to you saying that, oh, I'm gonna, watch some movie stream tonight. We're streaming it off of Netflix or things like that. So yeah, sure enough, those are also streaming, and they describe, all of these pixels of images, right? Kind of rendering on your TV screen, for example, things like that. But one thing I want to point out is that then it wouldn't be what, Apache Pulsar would be for. The kind of event streaming platform we're talking about are really dealing with data rather than like audio and visual. Those are kind of more special in a sense, even though, fundamentally they are the same, like bits and bytes kind of thing. But the thing is that you need to render these into like audio, you can hear it, or visual, you can see it on screen. That actually does require some certain amount of synchronous kind of processing to render them onto their respective media outlet, right? So that would not be able to kind of, or I should say, Apache Pulsar would not be what, its purpose isn't for those, but it's more for the data side of streaming processing. So. Okay, now then let's move on to talking about complex event processing. So as the word implies, right, complex, right? And as such too, this definition, I actually was kind of reading through different materials, and this I got from Conf, right, the Kafka kind of managed cloud platform company. So it's a good way of describing it. Is basically, when you deal with complex event processing, first you need to actually, and that's what is kind of confusing, I think, when you say, oh, we do things in events. But to me, in my mind too, and we all know, right, events coming in, you need to have some way of ingesting them. So that's kind of one part of this event kind of thing, processing kind of description of this whole thing. You need to ingest them and capture all of these data, and then you go through analyzing these streams of data as they arrive, right? And then the nice thing about using this event approach is that it allows you to do dynamic analysis, meaning that you ingest your data, you can immediately analyze these streams of data. Essentially, you don't necessarily have to kind of write them to database, to some sort of like persistent storage. And that's why too, it can become faster, much faster than if you have to kind of go through, loading your data to some database. And then we all know that any time of you need to do any kind of IO, disk IO, all of these, it takes time. So if you can do everything kind of in memory, that would be kind of really speed things up. So that's kind of one kind of purpose of it. But getting back to the complex event processing is that you analyze the streams of data, and then you kind of, it serves different purpose. I mentioned about like fraud detection system. That's a prime candidate of leveraging this approach of doing the computing aspect. Because, for example, you have fraud detection on your bank accounts, and at any given time, your all these activities that are about your bank account are being monitored. So if there are unusual activities, then basically, the system needs to know and then needs to notify, right? Essentially notify the account owner that, there's some unusual activities. Please check. You live in, I live in Chicago. All of a sudden, I see a chart out in Siberia or something. Something is wrong, and so you need to be kind of immediately be notified. So kind of using event event approach is kind of a good way of doing this kind of fraud detection. And so to just summarize, right, this complex event processing, it enables systems and applications to react to events, right? Have things happening, do you need to do something about it, right? And some trends too, like if you do online shopping, you want to be able to make, immediate like recommendation. If I'm like shopping around for handbags and then there are other kind of things, associated with handbags with different brands, could come and pop up all these ads for you to look at, right? So for kind of making recommendations and essentially looking at data patterns as they happen, you kind of do something about it. So it's kind of a complex event processing thing. And now let's then get back to like event into more of a messaging aspect. I want to kind of separate out too. There are people talking about streaming and then messaging too. They are kind of closely related, but they are not exactly the same, right? We're talking about different things kind of within the same realm, essentially. So, okay, so talking about messaging, there are essentially two types of messaging, so to speak, right? One is event-driven, and then the other is message-driven. So if we think of this aspect, so event-driven messaging, essentially, we're talking about one-to-many. One is one sender, usually, right? Or kind of just, well, for the sake of simplicity kind of discussion, one sender who emits messages, and then he or this messenger, so to speak, right? It doesn't know who the messages will be who will be intended to be the recipients of these messages. And neither does the sender care about what the address is of all of these receiver. It's basically, it will admit all of these messages and then it will label these messages, for example, in a messaging system such as Pulsar, Kafka, JMS too. These are called, you have to use topics essentially to categorize your messages. And so whoever is interested in these messages, they'll have to subscribe to the topic or this channel or this, kind of label. You need to categorize these messages. So then the subscribers will then receive the messages when there are messages available on that topic. So that's kind of essentially what event-driven is. And also too, it also means there's the addresses, they don't need to be published, right? Or kind of not published. They don't need to be known, right? You don't need to know that ahead of time if you're sending messages. So that's kind of more dealing with event-driven type of messaging. And then there's also message-driven messaging. And essentially that's kind of dealing with like one-to-one, point-to-point type of messaging is message-driven. Both the sender and the receiver have to know each other's address. So then you know where the messages should be sent to. So it's sort of like message-driven is a bit kind of likened to like the queuing type of mechanism to do when we're dealing with message-driven messaging. Whereas event-driven, then we involve a Pulsar, right? Kind of broker in between to kind of help you receive the messages and then deliver them accordingly too. So that's about messaging. And now, excuse me a second, just a little bit kind of dry on my throat. So, okay. So now, then talk about, let's kind of think a bit more too. We're talking about events, right? So this approach isn't for everything. I just want to point out, right, before we actually do things the event-driven ways, and I'm sure too, a lot of you probably have worked with some sort of batch processing system. And so it's sort of like they juxtapose each other. You either do things the event-driven approach or doing things kind of more batch up, meaning that you're both are ingesting some sort of data, but the event approach is that you want to process them as the data arrives and do something about it. So it implies kind of very real-time, kind of instantaneous type of kind of approach to processing your data as they come. Whereas then the other way, the opposite way would be like batch processing. You collect all your data and then process all of your data at a later point in time. So that kind of explains, you have to know what your systems are for. For example, you are working for a company that are dealing with like employee information system, and each employee, people move around, you need to change your phone number, change your address. And so you update your system through some UI. And then actually too, is that you collect all your data, but those data is basically being collected and they will all be batched up, during the day. And then at the end of the day, when everybody goes home, the systems are kind of free now and not having had to deal with, servicing things on the, instantly, then you will go through doing batch processing. So that's kind of an advantage to it, is that if you're dealing with kind of systems of records, doesn't require real time, then you want to turn to doing batch processing. The nice thing about it is that then if you do batch, as you can kind of imagine, right? It doesn't involve as much like networking kind of over the wire, because maybe you're updating your data, you collect them into a database, and then some processes doing the extraction and kind of like loading of data, it will all be done, all be ready, and then you just essentially crunch through all these numbers, this data through your server processes, and probably doesn't involve at all much networking too. So batch processing has this kind of advantage of not consuming much of your system resources in that sense. Whereas like event kind of driven approach, as you can see, you have to be instantly doing a lot of things, and involves a lot of maybe network traffic too, right? That type of stuff. Now, one point I wanted to make is actually when I'm kind of have done this presentation quite a few times, and people were actually asking about micro batching too. So that's another interesting thing, because it is true too. Even if you're using like an event-driven approach, you don't actually want to necessarily make a network call every time. Let's say I have IoT devices, right, in the fields, and you might be like, collecting all the data from your fields of temperature changes, things like that. There are tons of data, but instead of making, for every piece of data that arrives, instead of making a network call and send them to the server, maybe you want to do a micro batch, batch up, maybe certain time period, 1,000 devices collecting data, and then maybe you batch them all up and then send them all at once in one network call, things like that. So that kind of like involves a bit of an interesting kind of thinking, right? If we're doing event approach, how much do we want to do this type of like networking traffic, right, so to speak. So that's left for another talk that I'll do, but I thought I mentioned about it here too. I just think it's interesting, right? So, okay, now let's then taking a look into event messaging, kind of the semantic side, which is PubSub, publish, subscribe, or producers, consumers approach. So as such too, PubSub is an architectural design kind of pattern, kind of description. It doesn't dictate how you should implement your solution for doing PubSub. So, and as a result, you find in the market, right, there are lots of things there. Oh, PubSub, we're doing PubSub, all of these things. And Apache Pulsar as a broker is doing PubSub, yes. And Apache Pulsar has its own way of doing things. Kafka has its own way of doing things. There's Google PubSub. There is also other types of PubSub broker. And so they all kind of function differently. However, the very basic is here, right? You rely on having a broker as the middle person or agent. I liken it to sort of like a postmaster, post office postmaster. So you need to, I'm the one producing messages. So instead of me having had to worry about the address of the recipients, I just basically bring it to the post office and said, okay, label. I call it a topic or a channel. This is this message channel. So tell the broker, these are all my messages. So it's then you left it to the broker or leave it to the broker. Broker will then deliver the messages. And who do you send the messages to? It will be the subscribers, right? Those who are interested in receiving the data, they will have to subscribe to your topic or to the channel name. And then when messages arrives, and broker will then kind of go accordingly. Oh, there are all these subscription in here. I will deliver them accordingly, kind of like that. So that's kind of like fundamentally, that's what PubSub is doing in a nutshell, right? Okay, so that's PubSub. And then now we also have another approach, which is more one point to point. Now, as you can see, PubSub is more one to many type of messaging kind of approach. But here with message queuing is one to one. It's much like, we're all developers and we know Java, the data structures, right? And there's queues. So it functions just like that. Message queue is a queue, and, messages gets kind of queued up essentially. And the thing is too, they are stored in the queue and then they will be removed once a consumer comes and pick up the messages. So that's kind of the differences, is more of a point-to-point, one-to-one type of kind of a pattern in here that we're looking at. Now, both approaches too, the good thing about this is you decouple the sender and the messenger. So it makes the scalability aspect to be much better too, because you don't need to be, kind of dealing with a lot of times too, sometimes if you're kind of the traditional way of doing things, and you have to remember the address of who you send messages to. If you have more, receivers, then you have to have more concern of dealing with where to deliver things to, right? Who you deliver to. But this way too, you kind of decouple them. So it helps with the heavyweight kind of processing. And if you need to buffer up, batching work too, it just helps in this aspect of it. So, okay, so those are the semantics. So let me look at the time. So, okay, now then let me look into event streaming, essentially a step beyond just the messaging aspect, and also like what is driving the change. I already kind of talked about some of these, but here let me summarize again. Essentially too, it allows you, to do things or basically handles data in a real-time kind of way. You enable data to be processed, to be acted upon, in the real time. So it helps too in kind of designing solutions for your systems. You enable your customers to be able to get real-time kind of results, and it's just faster. Essentially, it's this very responsive applications. And another aspect is that using like event streaming, you can also build like data pipelines. So what does data pipelines mean? They are essentially, you have source of data arriving, and and basically with that you can have data travel through a pipeline, so to speak. So inside the pipeline, you can also be applying different, kind of methods, or so to speak, functions, right, to modify, transform your messages or any kind of remediation that needs to be done. And when these data have been transformed, then you can output it to a source or actually a sink, right? The sink is where you collect the resulting transformed data like that. So that's a data pipeline. But the idea is that, at least theoretically, you should be able to connect, your different data pipelines together. So then you output to a sink. That sink can become another topic, and another topic that will, basically source of data for another data pipeline. And hence you can then build up your whole flow of your data through different pipelines. Now, the thing is too, in AI and machine learning kind of scenario, they will be good candidate of using this type of approach, because you are essentially ingesting a lot of data, right? So a lot of data you need to go through, and you also need to like analyze them right away and turn them around, and essentially that will update your data model too, right? In AI type of applications, the data model keeps changing, because based on the input of the data, you have algorithms that analyze it and then generate updated model as it goes. So very dynamic. So essentially, you can kind of use event-driven approach, and also here too, it talks about like time series event streams. So that will be kind of perfect candidate to leverage on an event streaming platform. Okay, and then the third thing about using event stream would be scalability aspect, right? And essentially, we kind of already talked about it. It can scale much easier if you're using if you're developing an Internet of Things kind of, application, a system in like, a farm, a field, collecting weather data, collecting wind speed, things like that, right? So you have all these sensors, and they're constantly monitoring the change in all the weather data, and then sending data to the server. And, it helps too, tons of data putting in, you need to add more devices. It can scale quite well. And of course, it also then relies on your broker too, but that will be another kind of a talk to kind of get into that detail. But that essentially is what it is. Here, just a quick summary too. So it allows you to basically watch for events with the system or the application. And then also too, because of the nature of subscriber, right? You subscribe only to messages that are of concern to you. So it sort of acts as sort of a filtering off. You have tons of messages, but if you only subscribe to the ones that you're interested in, so you only receive those messages that are of concern to you. Okay, and then also it allows you to essentially make decisions on the data in real time, and not after the event, right? And also allows you to ingest high frequency of messages, and also then respond back with low latency. So this responsiveness is already kind of built into this approach of computing. And here too, just to show you too, if we're using streaming, and then if we're not using streaming, the one in the bottom too is like not streaming, essentially too, traditionally, right? When we're doing we're already doing some form of streaming, but the bottom approach, not streaming, is describing you're ingesting data, and then you actually persist the data to some form of storage. Usually it's a relational database, right, or something like that. You persist the data, and then from there, then you have to then select the data again and sort through them and process them, and then write them back into another table, maybe inside your database or another database, and then so on and so forth. And then when you need stuff, you need to select data again. Now that will work, but of course, as I mentioned earlier too, it involves a lot of more disk I/O, and so it naturally will slow things down. It's just not as efficient. However, if you look up there, right, streaming, you ingest the data. In fact, you get the data already there, and you can process process the data as they come in, like say in memory and all that. And then when you're done, you output it to some sort of using some connector, you output it to a sink, right? The sink can be JDBC kind of sink and data into the database, or into even, for example, in Pulsar's case, it supports like third-party sinks such as Kafka Sync or Elasticsearch Sync and all of these other things too. So then you can immediately kind of do select data. It's basically eliminating a lot of the disk extra need for doing all the persisting data to disk I/O, all of these. So, okay, so now then let me talk about Pulsar. I talked too much about the other thing. Okay, so Pulsar, what is it, right? It's an open source project, Apache Software Foundation project. It originally was created by Yahoo back in the early 2010s, in that kind of time frame. At that time, right, Yahoo was already quite ahead of time in terms of being a cloud consumer, right, using cloud. They realized that, well, the tons of data that they have to manage, for the different services are kind of growing leaps and bounds, and they need to have better ways of handling data in the cloud and doing replication, for example, geo-replication, handling, you have tons of messages, and they need a messaging, essentially very fast kind of distributed messaging system that can operate well in the cloud. So that's when engineering teams started developing Pulsar. And then in 2016, they contributed it to ASF. And then very soon, 2018 already became a top-level project, because people are starting to recognize, okay, we need a system that can be doing event streaming and also function very well in the cloud environment. So Pulsar itself is very much a cloud-native aware type of event streaming system. I call it like cloud native, was born with the cloud native DNA, is already in there. So things that all operate on a cluster-based system. And then also, it supports this multi-tenancy kind of concepts, which means that, you have all these messages and all these ways of data coming in, but there's also this kind of structure that you can essentially demarcate all of your different, kind of categorize all of your messages. Some are maybe for, let's say in a business functions, you can have product teams own this one tenant, they're owner of that tenant, so they manage all of these things and messages within it. And you can have a marketing department is also considered another tenant, that type of stuff. So it helps you to structure your data accordingly. And then also too, and if you want to work with Pulsar, it's flexible, the client APIs. You can, by default, right, broker is written in Java, primarily Java. And so it supports Java client. But if you don't use Java, if you are a .NET, you're person, you're writing in C#, you can also use C# client to talk with the broker too. And then Python, Go, and other community contributions such as Scala, it also supports too. Another big thing about Pulsar is that it separates out the compute and the storage. This means that, with all of the messages coming in, you have so much, right? And instead of Pulsar worrying about managing all of these messages, they can become quite messy, so to speak. So Pulsar delegates it to Apache Bookkeeper. So another Apache project, and Bookkeeper's, that's its specialty, is to manage data in bulk, right? And also too, the way it writes the log messages, they are append only, so it's also like very fast too. So in other words, right, all of the log messages that comes into your system, Pulsar doesn't deal with it directly, but have Bookkeeper handles it. So later you can actually look up messages that are there, and using Pulsar, this this feature called like cursor. You can actually navigate through it, and then programmatically it's doing the reader interface. You can actually get through all of your messages that are already kind of in your storage essentially. So that's all managed by Bookkeeper. So that's kind of nice, because if you need to, anytime you need to scale your system, you're adding another node, another cluster to your infrastructure, it can kind of scale, the whole system can scale quite well, because then Pulsar worries about the compute side, and Bookkeeper will worry about, okay, I'm going to manage all of my messages, spread them out there, their topics, your multiple brokers, and they all scattered everywhere. You need to add another node. You need to rebalance all of your topics. Pulsar will do that for you automatically. Okay, and then there's also the third thing here listed is the guarantee message delivery. So anytime we know we're dealing with asynchronous messaging systems, you are subject to the network connectivity too. Sometimes the network may not be kind of up all the time, but fear not, your Pulsar, the broker, it does a lot of work for you in terms of guaranteeing your messages gets delivered properly. It will be like exactly once, or at least once. These kind of QoS level it supports as well. So let's say if your network goes down, don't worry about it. The broker, when the network comes back, the broker knows and will kind of resume, and knowing you have these messages waiting to be delivered, it will deliver for you. So. Okay, and then the fourth thing is about the serverless functions framework too that Pulsar has. It's called Pulsar function, and essentially it's think of like AWS as lambdas, and they are kind of allow you to write kind of short programs, small programs to kind of modify your messages as they are traveling through the pipeline, kind of like that. So Pulsar has this function framework too. So then you don't need to use any other third-party library to help you do it too. So you can leverage on that. And then there's also this feature is a tiered storage offloads. And what it means is that, sometimes your log messages becomes kind of stale now. You've been like hanging on in the system for too long, hasn't been acknowledged and all of these things. So Pulsar kind of just still has it. But the thing is, Pulsar will know if it has been in, kind of essentially in the hot, kind of, or the data is aging out, right? Then it knows, and it will move from the hot storage to the cold and long-term storage for you. So in some ways too, as developers, sometimes we don't want to deal too much, right, with all of these infrastructural concerns. They are very important, but it's nice to have a system that actually will handle that aspect for you. So yeah, just know that about that. Okay, so this slide just quickly shows you too that Apache Pulsar is increasing in popularity, right? Look over here, number of GitHub stars keep growing. Number of contributors too also keep growing, and even I think in 2021, so a year ago or so, we are already seeing the number of Pulsar open source committers have actually surpassed that of Apache Kafka as well. So. Okay, and then who else is using Pulsar? So just a quick kind of look for you. It is still kind of relatively new now, because became kind of top level project 2018, 2019 in that time frame. So there's also another company called Stream Native. Actually, they are the ones that are have a few of the original Yahoo Pulsar team members that are in there too. So so between DataStax and then and Stream Native, and then also a couple other companies like Splunk also is a contributor to the open source project, and a couple of China companies too. So these are the ones, they're also using it, and there are a lot of markets also in China too that are using Pulsar already. Okay, so Pulsar is different, just very quickly. This one I won't kind of go through, I already talked about. If you think of Pulsar, they're just primarily, on an architectural level, you have the producer, right? You have consumer, and then broker is essentially a stateless process that will, broker is important too in this Pulsar ecosystem, because it handles all of the incoming messages, message dispatching, communicates with the Pulsar configuration store. It stores messages in the Bookkeeper instances. It coordinates with the Bookkeeper too. So that's kind of the, broker being the central piece in here. And then Bookkeeper is very important in terms of managing all of the persistent message stores for all of the log messages. And then we also rely on Zookeeper. Zookeeper as such, is the one that oversees your, your whole kind of meta cluster, metadata, your cluster handling coordination tasks between Pulsar cluster, all of these things. So. And also, this thing I want to point out is it uses a tiered architecture design, multi-node architecture too. So some of these things I've already talked about is that, for example, in kind of a complex system, right? Anytime if you need to scale, it can be so complicated. But the thing is with Pulsar is that it takes care of partition rebalancing. So as such, right, you have broker, you have different topics, but in order to increase throughput, by default, right, Pulsar has one broker. But the thing is, most of the time too, you actually are using more than just one broker. This will help in the overall like message throughput too. And also you want to partition your topic. So then a topic is being handled by, they're partitioned off, so they're handled by different brokers as well. So in the cases in which you need to add another node to your cloud infrastructure or another like a node or a server, for example, then you need to make sure your topics, kind of the partition topics, get spread out evenly, right? All these things. So internally, the Pulsar infrastructure will take care of things for you too. So that's kind of a nice thing. So. Okay, this one too, I just very quickly kind of I just want to point out here, right? If you look into this bookie layer, as you can see, broker is the middle piece and zookeeper is the one overseeing everything. And then you have your clients coming in, your producer and your consumer kind of interacting with the broker. Broker will then do all the servicing, but then it talks to the bookkeeper, right? Bookkeeper has its own way of managing all of the log messages. If there, any given point in time, you have multiple instances of bookies running, and they also do this segmented approach of segmenting all of your log messages accordingly, and then managing them by different bookie units too. Essentially, too, kind of one thing highlighting is that bookie will has this following this spec is called WAL, is the write ahead logging based kind of specification, and it's very sophisticated. It guarantees, fault tolerance, low latency read and write, and that type of stuff. And also guarantee the integrity of your messages, your log messages too. So some of these things too is tunable. For example, consistency, message replication, all of these things too. So you just kind of rest assured, it is a very sophisticated system that handles all of your log messages for you too. So. And here, let me just quickly summarize again. Apache Pulsar represents the next generation of enterprise messaging. It's a unified solution for doing PubSub, doing queuing, to streaming and message mediation and enrichment. And then out of the box capabilities will include like cloud, you can run it in the cloud, or if you want to do on-prem and hybrid, it supports all of those. And it also supports this feature, it's called geo-replication too, which I'll discuss in a little bit. And then there's also support for multi-region, also like data lakes, integration, other kind of, you need to, for example, work with, Pulsar can act as the source and then allows data to flow through, and then essentially to feed the data into different analytics engine, such as like say Apache Pinot, Apache Flink, and all of these. We work with those too. And in fact, here in DataStax, we're also having partnership with some of these commercial companies that are supporting these other Apache projects too. So, okay, so that's that. And then this one, I won't step through this, how is it different, but I wanted to bring your attention to this again. Key differentiator of Pulsar, right? It separates between compute and storage. So in this particular diagram, as you can see, right, all of the architecture is tiered architecture, all distributed. It separates compute from the storage, right? The scaling is all independent too. If you need to add another cluster, to your, or actually another node to your cluster, your infrastructure, is basically they all scale independently. So then it's kind of very clean separation of concern. And then over here, I wanted to say, this here highlighted, talk about fast and low impact horizontal scaling capability. So horizontal scaling is anytime you need to increase the capacity of any of your whole ecosystem. Horizontal is you're throwing in additional cluster, into your whole kind of overall ecosystem, things like that. So you kind of, get growing side, at the side rather than vertically. You're not necessarily adding more, just memory or disk to a server. You are actually adding more servers to your whole ecosystem, things like that. So by using like an event streaming platform like Pulsar, which is so cloud native ready, it actually handles all of this scaling without you having had to worry about it. So. Okay, and then the second thing, the second differentiator here that I want to talk about is geo-replication. So it is kind of a native way of doing replication. That's something that you do not need to write additional functions or plugins to handle trying to replicate your data between different data centers, right? Some of the production topology, you could be involving a whole world, right? You have data centers in different regions of the world, in Europe, in Asia, in America, all of these. And so Pulsar already has this, again, kind of a native way of helping you to do replication. For example, over here, right, I talk about the message replication mode and patterns like synchronous versus asynchronous, active, passive, all of these things. You can actually be doing replication even though your system continues to run too. It can do it while your nodes are active like this. And also another good thing about this is it has selective message replication, meaning that, maybe you don't want to necessarily replicate some data across different regions because, for example, in Europe, you have GDPR kind of regulations on privacy data. So that's for sure, you don't want to replicate any sensitive data from Europe into America. That's no, you don't want to do that. So on the Pulsar, you can configure it so then it knows when it comes time to do replication, it will only replicate the relevant data for you. Things like that is already built in. So it's kind of makes your life much easier too as developers. Okay, and then the third differentiator here is about multi-tenancy. Is, if you look into it, right, this is just a diagram to your right side. Pulsar cluster, you can divide up all your data into different, managed accordingly by calling it different tenants. One is for managing finance, the other marketing, product, all of these, they have their own namespace. You can have multiple namespaces within it. That kind of helps to control how, data is being accessed within your business functional way of organizing, right? So it helps too with a bit of operational simplicity in that sense. Security, compliance, auditing, all of these things. And so it helps essentially too. You can have message flow control. How do you throttle all of these things too? You can handle it easier in that sense. So. And then this one, the differentiator 4 is basically more on the client side. Client meaning, well, the receiving client side, right? On the subscription side, I should say. And so if you kind of look into it too, there are multiple subscription modes that are being supported. First, the top one, essentially, that will also exclusive mode is almost seems like turning Pulsar into a message queue. That enabling it to do message queuing because you're only allowing one consumer per subscription. So it's effectively turning it into a one-to-one kind of a queuing type of mechanism, right? You only allow one consumer. That's exclusive. If you need that, message ordering is always guaranteed to. And then another one is the second one is failover. Failover is essentially, as the name implies, you have a primary consumer. You define one or more other consumers, and they act as more like backup. So then if the primary one goes away, then any of the backup consumers can step in and take over essentially. So that's also guaranteeing message ordering in this case. And then the third one down here is called shared. Shared subscription allows one or more consumers to be defined for that subscription. And however, for the shared, it doesn't guarantee. It may or may not. It's just not as guaranteed in terms of the message ordering aspect. It's very essential in a cloud native type of environment because sometimes, well, okay, I won't go into all the details because I realize I'm running short on time, but I want to also kind of point you to the fourth subscription is key shared. So key shared, essentially, it allows the message ordering to be guaranteed. So that's important to you for multiple consumers per subscription, then key shared would be the mode that you want to use. So, okay, so that's that. And now, okay, this one I actually won't go through, but I want to highlight a couple of Pulsar developer features. First of all, data pipeline, right? When we deal with event messaging, event streaming, basically, you are talking about data coming out of a faucet. It's much like traveling through the pipelines. And then you need something like to transform because there's certain data maybe you want to filter off or do whatever you need to do. Essentially, that's where Pulsar can come in. You can make use of Pulsar function to help you to do that. When it's ready, the data is ready at that stage, right? You can then output it to a sink, right? Over here, output to a sink. The sink is the place where you receive the transform data. So that's a kind of data pipeline kind of concept. And again, that we have Pulsar functions, and it allows for kind of complex stream processing, right? But they're very nice because they're very lightweight. It's essentially function as a service. It's inspired by AWS Lambda, Google Function, all of these things. Currently, too, is supporting only Java, Python, and Go, but there are already works being kind of done to support other languages as well. So as you can see in the diagram here, it's just multiple topics, right? Input messages, and then essentially, too, it comes in and Pulsar function. You can write Pulsar functions to transform these data, and then essentially then output messages to another topic, to a sink, and you can kind of turn that output sink into another topic as well. And also too, you can have what is called like log topics as well. They're more for the logging type of purposes. So. Okay, and then there's also this feature called Pulsar schema. So as we know, we're doing, kind of remote calls and all of these things. You need to worry about serializing your data and deserializing, right? When you send and receive data over the wire. And if you don't kind of define all your data objects, essentially you need, using Pulsar, you will need to convert your data to byte arrays. So it can get kind of messy if you have changes in your data over time, you kind of have all of these. So why not use like Pulsar schema, for example? So the schema will essentially allow you, it's kind of like a registry for you, right? It's built in, and it supports like different data types, like primitive types or like key value pair, different formats like Afro format, JSON, protobuf, it all supported. Also too, the nice thing about this feature is it also helps you track all of your versioning. So, over time, your data kind of grow and shrink, your data structure, all of these things, and it will keep track of the versioning of your schema changes too. So that you can kind of consider using it if you're interested too. Okay, and then this one too is it's called Pulsar IO, is another feature. This one allows you to build your own connectors. I talked about the data pipeline, right? We have source and then going to Pulsar and then going to a sink. Essentially too, the source, if by default, right, there are certain types of source. For example, I actually forgot that maybe another like Astra database is the DataStax managed cloud platform for Cassandra, right? That can be a source too. But let's say there are some sources that you want to do and it isn't already there. You can actually build your own connectors using this Pulsar IO kind of the kit, right? Development kit too. And then likewise too, if you want to output data to a sink, I mentioned about Kafka sink, Elasticsearch sink, and there are other sinks too that you want that we don't already support. You can use the Pulsar IO, again, that SDK to develop your own sink connector too. So it's pretty flexible. Okay, so this just very quickly kind of let you know, because I work for DataStax, so just to let you know, we have this platform I mentioned already, managed cloud platform called Astra Streaming. There's also Astra DB, so that's for managed Cassandra, but we also have managed Pulsar now. There's also a $25, like US dollar for free every month for you to try things out, no need for credit card, and I'll share the link with you. Then there's also Luna Streaming, if you're interested in hosting your own, kind of on your own cloud, Pulsar too. There's Luna Streaming, and it's all free. Obviously, you host it yourself, but you can also purchase our enterprise support too. And then the other one is completely going open source. You can always rely on the community and participate in the community too. And then here too, some additional information for you. Pulsar now also supports like RabbitMQ, Kafka, and JMS. So at DataStax, we have this API that we have that you can use. It's called Starlight, and Starlight can help you connect to all of these external message queues and message handlers too. So. And this one, I guess I won't go into all of these. I'll just skip for now. But if you're interested, you can also take a look. We kind of support this feature called CDC, Change Data Capture, too. Much like if you're familiar with open source like Debassium, it's kind of same kind of concept. But CDC specifically for the Cassandra and on our managed cloud platform too. So yeah, if you're interested, actually not just that. I think it's on Cassandra. But oh yeah, so the Cassandra CDC can also work with Luna Streaming. And then if you want to use our Astra database, there's CDC that are specific for Cassandra with DataStax, and then working with the Astra Streaming, which is Pulsar underneath the hood.
Hi,
all right.
Mary.
I'm sorry. Yeah.
I'm sorry, we are almost out of time.
Oh, I'm time? Yeah, I'm sorry. Okay, all right then. Can I kind of just very quickly? Yeah,
Absolutely. Thank you.
Actually, I'm almost to the end. I was going to kind of show some quick demo, but I think I'll just show the link. So where do you go from here? I always talk too much. Okay, so this is like all the resources. So please feel free. I'll share the slides. Again, Pulsar, Bookkeeper, Zookeeper, Astra.datastax.com is where you can sign up for the free cloud platform. And then all of the DataStax resources in here. And then also this one is the page for if you're interested in additional credit, $200 US dollar, you can use this code and this link to sign up for additional credit too. And then, oops, where am I? Am I in here? Oh, no, here, sorry. I don't know how I kind of got to, okay, sorry. Everybody can still see this, right? Okay. And then the next thing is about our 5 minutes about Pulsar on YouTube. So if you want to visit that, we also have tidbits about that too. And then my own Twitch stream every Wednesday afternoon if I'm not traveling. So please follow me on my Twitch. I'll actually have time to do some demo in there, and you can participate in the show too if you want. Also, and this one, we have an awesome Astra for if you want to do more kind of hands-on coding, how do I begin? We have DataStax as this awesome Astra that site, right? We're dealing with not just like our own thing, but there are also like open source software everywhere. And then join us on our Pulsar meetup and Pulsar neighborhood. And also, this is how you can get a hold of me. So yeah, okay, I'll go back to Helen now. Thank you.
Thanks, Mary. Okay, wonderful. I believe we are going to be sharing the slides if we haven't already. Yes, thank you. Matt's already done that, so you'll be able to get the QR codes there. Mary, that was amazing. Thank you so much. The audience agreed as well. We've got someone said, this is awesome, wants to learn about this stuff. Great explanation. Thank you very much. Excellent introduction to this topic as well.
Thank you.
We do have 2 questions in 1 minute. Does Pulsar deliver events in the same sequence as that in which they are published?
Oh, okay, that's a good question. So as I mentioned about, right, there are different subscription mode. So message ordering is guaranteed if you use exclusive failover or key shared. But other than that, then if you use only the share mode, that may not be guaranteed. So yeah, I hope that helps. Yeah,
that's wonderful. Thank you. Next one, how flexible is Pulsar in terms of implementation compared to other messaging systems?
Okay, flexibility. Yeah, I would think, right? I like to think of it as very flexible because also of its cloud native nature. But one thing is true is that it's still relatively new. So there's still some experimental kind of feature or things that are yet to be done, a lot more benchmarking too. But I'd say it is flexible. It is a very promising platform for doing event streaming in the cloud. So yeah, please give it a try. So thank you.
Amazing.
Yeah, thank you.
Mary, thank you so much. Do you have any final thoughts that you'd like to share before I have to remove you from the stream?
Yeah. Well, for me, I just want to thank you again. Final thoughts. I think this is an exciting area, event streaming or anything in computer. I think I'm just a passionate advocate. I like to come out and talk with other people, learn from them. I think I encourage everybody to do that. Yeah, there's no exactly right or wrong, but just kind of be creative, right? Listen to all these ideas and then come up with your big creative ideas. I think that's the goal, just to be an inspiration to others and, kind of be inspired as well. So thank you. And I got inspired by your whole team, Helen. I love your team so much. So yeah.
Thank you. And Mary, once again, thank you so much for joining us. It has been a pleasure. Safe trip home, and thank you.
Thank you, Helen. Thanks, everybody. Have a good day.